Hello class, this is our notes for sections 317, 318. We're looking at solving quadratics and complex solutions, and then also which method should you use for solving. That's kind of our bigger focus for today. So first we're just looking at complex solutions and talking about how we can put together our knowledge of imaginary numbers with what we already know about solving, and now we can solve all kinds of things. So in previous sections, we've encountered quadratic equations that have no real solutions. For example, the quantity x plus 2 squared equals negative 2. So in general, when solving something squared, it has to equal when something squared has to equal a negative number, there are no real solutions. So remember, if I go to solve this, square root on both sides, can't square a negative. But now, because of our knowledge of complex numbers, so remember complex numbers are a plus bi, they have a real and an imaginary part, or they could just be imaginary, right? We can solve an equation without any real solutions using imaginary numbers. And this is going to seem, the first little bit here really feels like review from what we did in our last section. So they're saying, hey, take the square root of negative 1, or sorry, take the square root of negative I, make it the square root of negative 1 times a, sorry, square root of negative a, negative 1 times a, which is square root of negative 1 times square root of a, which is I root a. So we've done this. This is review for us. So we're going to try solving using a couple different methods. First is square roots. So square roots, I would subtract 4 on both sides. And my idea with the square root method is to get this part that's being squared by itself. That's what I want to do. So I'm going to subtract 4 on both sides. So 2 times the quantity x minus 4 squared equals negative 18. Then I want to divide both sides by 2. So again, I am trying to isolate just the squared part so that I can take a square root. Then I have the quantity x minus 4 squared equals negative 9. Okay, now that I have my quantity squared by itself, square root both sides, and the absolute value of x minus 4 equals square root of negative 1, square root of 9. Really, it should be in the other order, but that's okay. This is going to be x minus 4 equals plus or minus. Usually we're going to write the whole number first and then the I part. So I'm going to write it as 3i. So now my last step is adding 4 on both sides. So x equals 4 plus or minus 3i. All right, the next one says complete the square. But the first thing I notice is I have a 3x squared here. So it's hard to complete the square when you have a coefficient. But what I do notice is the 3, 24, 90. I can divide them all by 3, and so I'm going to go ahead and do that. So let's factor a 3 out of everything. And then we have x squared minus 8x plus 30 equals 0. So let's go ahead and divide both sides by 3. And because it's just a constant, it's going to go away. 0 divided by anything is just 0. Now I have x squared minus 8x plus 30 is equal to 0. So I know for complete the square, I want to move the constant part over. So I'm trying to get the x squared minus 8x together on one side. So minus 30 on both sides. And then I want to think, what could I add to complete the square? So let's remember, we figured that out. We took that middle coefficient, in this case, the negative 8, and it doesn't matter negative or positive, because when we square it, it's going to be positive either way. We take that middle part, and we divide by 2, and then we square it. So negative 8 divided by 2 is 4, squared is 16. So I want to add 16 on both sides to complete the square. So on the right-hand side, I now have negative 14. On the left-hand side, x squared minus 8x plus 16. Well, that's going to be the quantity x minus 4 squared. So let's remember that 4 times 4 equals 16, and the negative 4 plus negative 4, when I double that up, it makes my middle term, that minus 8x. So now that I have a squared part, a squared quantity by itself equal to a negative 14, I'm going to square root both sides. So now I've got absolute value of x minus 4 equals square root of negative 1, square root of 14, which means x minus 4 equals plus or minus I root 14. So remember, like with the 3i, we put the 3 in front, but with the root 14 and the I, we put the I in front, because we want to make sure that people know it's the square root of 14 times an I and not a square root of 14I. So it's easier to tell the difference if you put the I in the front. Then you don't have to worry about how long that square root is. So we usually put I's in front of square roots. All right, now I would add 4 on both sides. Oops, I'm still in my eraser. And then I have x equals 4 plus or minus I root 14. Okay, the last one here, so they're not actually asking us to do factoring and zero product property because it's really a fourth method. But the last one here is quadratic formula. So quadratic formula, first I need to have it in that form, ax squared plus bx plus c equals 0. So I'd have to add 5 on both sides. Then I've got x squared plus 2x plus 5 equals 0. So let's remember that a is my coefficient on x squared, so that's a 1. So a is 1, b is 2, c is 5. So quadratic formula is going to be negative b plus or minus square root of the quantity b squared minus 4ac all over 2a. Remember, I'm no longer telling you guys what this is. There's a great Pop Goes the Weasel rhyme. If you have trouble remembering it, I cannot sing it, but you could certainly look it up. So x equals negative b, that's going to be negative 2, plus or minus b squared, so 2 squared minus 4 times a is 1 times c is 5, all over 2 times 1. And then remember our next step is to go through, do a square, multiply, multiply. All right, so x equals negative 2 plus or minus 4 minus 20. And this is all over 2. Now we're going to subtract. Negative 2 plus or minus square root of negative 16 all over 2. Okay, so square root of a negative 16, remember that's a square root of 16, square root of negative 1. Square root of 16 is 4. Since it's a negative, it's just going to be a 4i. So negative 2 plus or minus 4i all over 2. So let's remember how it works when I am taking this whole fraction, taking this whole thing and dividing by 2. I could distribute that division. So I could make it x equals negative 2 over 2 plus or minus 4i over 2. So that's going to be negative 1 plus or minus 2i. All right, so here is our first page done. Just did a quick review of all those different methods, right? Square root, where something's ready to just take a square root right away. Complete the square, where we added that magic number to make it into something we can square root. And then quadratic formula. Quadratic formula is the one that always works, but it's kind of tedious, and we don't want to do that unless we have to. So the next page is really just talking about the different methods to use. So finding square roots is great if it's already a perfect square. That's a really easy one. So there's some great examples over here. This one I have x squared and 81. I don't have that bx part in the middle. It doesn't exist. So it's real easy to add 81 on both sides and take a square root. It'd also be easy to factor though. Second one I could divide by 2 and take a square root. Factoring, if the equation is easy to factor, remember to always factor out the greatest common factor. So greatest common factor, GCF. So like on this one, there's no middle term. And then, which is like my x term. This one, notice there's no constant term. So easy to factor, that's just a greatest constant, or greatest common factor kind of thing. So kind of watch out for those. Next one, complete the square, can be used on any quadratic equation, but it's easiest when a is 1 and b is even. This should be ax squared plus bx plus c equals 0. So I wouldn't use it if a wasn't 1 and b was even. I just wouldn't bother. And then quadratic formula, of course, is for any quadratic equation, but this is really when nothing else works, when all else fails, right? That's when we want to do that. They're also suggesting graphing, but we don't really want to do that. We want to have the graph paired in our head with what solutions might look like, but we don't really want to spend time doing that. So we're going to go through first, and we're just going to look at which of the methods would I use. So like on number 1, I have a quantity squared right away, so I would use the square root method. On the second one, I'm recognizing that I can factor this, so I would factor and use zero product property to solve. Okay, and you're going to get better at recognizing when things are factorable. 3, it almost looks factorable, but if I think about subtracting 9 on both sides, it really isn't factorable. But I do have y squared and 6y on one side and the constant on the other. And this is a 1 and the 6 is even, so I would complete the square on this one. All right, on the next one, I can see it'd be easy to isolate p squared. 6 is just a constant, so we could subtract 6 on both sides and then just solve right away. So I'm going to write down square root method on this one as well. The directions say we're only supposed to do the quadratic formula twice. Okay, next two. 5, again, there's something already being squared, so that means square root method. That one's easy. And the last one, it looks like it's set up to factor, so let's just check it really quick. Is there anything I could multiply to make 1 and add to make -1? And the answer is no. This is a 1 and this is not even. It's an odd because that's 1 also. So that's one where I'd want to do the quadratic formula. So let's go ahead and you're going to try the first page. And then actually, you know what? Let's talk through the second page and then we'll do a few at a time. 7. Let's see, there's a 4 and a 16 and a 4. So I would first go through, divide them all by 4 to get a better look at what's going on. And then I've got r squared plus 4r equals 1. That seems like it's not factorable. It's definitely not factorable. So I would just complete the square on this one because we have a 1r squared and 4 is even. On the next one, this is going to be quadratic formula. I definitely cannot factor this. So I'd have to start by adding 5 on both sides. 5x squared plus 2x plus 5 is equal to 0. So A would be 5, B is 2, C is 5. The last two, let's see, on 9, I would want to divide by 3. When I divide both sides by 3, when I divide the right-hand side by 3, remember, it's like distributing that division. I'm really taking -30 and dividing by 3 and the -27 dividing by 3. So x squared equals -10x minus 9. I'm pretty sure this one's going to be factorable. So let's just make it equal to 0 real quick to check. So remember, because I'm trying to make it equal to 0, I'm allowed to do the plus 10x plus 9 in one step. Otherwise, I would not be. This one's definitely factorable. So we're going to factor and use 0 product property. This last one is missing my constant term. So that's going to be a factor in 0 product property as well because there's no constant term. So what I would do is subtract 10n on both sides. And then I'm just going to factor with my greatest common factor here and put something in front and factor that one. All right, we've kind of gone through and sketched everything out and just thought about it. So I would like you to go ahead and pause and try the first 6. And then I am probably going to work through them pretty quickly because I think we're good at this stuff by now. I don't think you need me talking you at length through all of it. So go ahead and try 1 through 6, and then you could unpause and just kind of watch me work through them. So the important thing to remember with this one that has a squared quantity is that we're really trying to get the squared part by itself. So I've got to add 8, I have to divide by 2, and when I have that x plus 5 quantity squared equals 6 left, that's when I can square root both sides. So after my square and my root, I have an absolute value, and I don't need to write out the 2 separate equations because it's just square root of 6, and I can't really add and subtract numbers from that. So x minus 5 equals plus or minus root 6. Add 5 on both sides. X equals 5 plus or minus root 6. The next one, we said factor and use 0 product property. So if you get stuck on the factoring, we could always use the box method. So I have a 2x squared and a -15. 2 times -15 is -30. I want to multiply to make -30, but add to make 1. So that's going to be a 6 times -5. Those multiply to make negative 30, but 6 plus negative 5 adds to make a 1. So I can put 6x and negative 5x in the two remaining boxes. It doesn't matter which order they're in. And then I go through and I look at greatest common factor for all my rows and columns. And then my last step is to double check and make sure everything works. So if I look at the 2x and the x, they multiply to make 2x squared. I can go through and check all of the boxes and make sure my answer is right. So now that it's factored, I'm going to go ahead and write it out. 2x minus 5 times x plus 3. And then I would make each of those factors separately equal to 0. This is that zero product property part. We want you to show all the work on this. So I'm showing adding 5 on both sides, dividing both sides by 2. So 5 halves is equal to x, or negative 3 is equal to x. All right, so that's all set here. For number 3, we said complete the square. I need to kind of erase this 1 here. It's bugging me. But I do want to go back and box that in. All right, so y squared plus 6y, so I have to do 6 divided by 2 and square it. And that would make 3 squared is 9. So I want to add 9 on both sides. So that means on the left, when I look at that y squared plus 6y plus 9, I would factor that as the quantity y plus 3 squared. On the other side, I would have 18. So let's go ahead and square root both sides. And then we've got absolute value of y plus 3. On the right-hand side, we know 18 is 9 times 2. So square root of 9, square root of 2. That means y plus 3 equals plus or minus 3 root 2. And now I'm going to subtract 3 on both sides. All right, all set. The next one, we already said, hey, we need to subtract 6 on both sides. So that means p squared equals negative 121. Now that p squared is isolated, I can take the square root on both sides. Absolute value of p is going to be square root of 121 times the square root of negative 1. That means p equals plus or minus. Square root of 121 is 11. Square root of negative 1 is I. So we are, remember, solving over the set of complex numbers. 5 is set up to take a square root right away. We'll do that on both sides. So the absolute value of m minus 7 equals, let's see, square root of 4, square root of negative 1, square root of 2. So m minus 7 equals plus or minus 2I root 2. Last step, add 7 on both sides. So this is our preferred order: whole number, I, and then square root. Last one, we said quadratic formula on this page. So my A is 1, B is negative 1, C is 1. It's kind of interesting where they're all ones. So x equals negative b, which would be positive 1 plus or minus quantity b squared, so negative 1 squared. Don't forget about the parentheses around negative 1, minus 4 times 1 times 1. So this is just quadratic formula. You do need to have this memorized. All over 2 times 1. So 1 plus or minus 1 minus 4 all over 2. X equals 1 plus or minus square root of negative 3 all over 2. So since it's a negative 3, I can't take the root of 3, but the square root of negative 1 is I. So I'm going to write it as 1 plus or minus I root 3 all over 2. And remember, we can distribute that division. So you could totally leave it this way. That would be a fine answer, but we could also take it a step further and write it as 1/2 plus or minus 1/2 I root 3. And really it could be root 3 over 2I. Like, I think there's a lot of different ways to write that one out, but this would be like consistent with the way we've been doing in class. All right, go ahead and pause again and try the next 4. All right, so to complete the square on 7, hopefully you've tried them on your own. I take that middle term, 4, divide by 2 is 2, and then square root is 4, so I'm going to add 4 on both sides. So then I'm looking at taking r squared plus 4r plus 4, that's what I'm factoring. So that's going to be the quantity r plus 2 squared. On the right I have 5, and then I'm going to take a square root. So absolute value of r plus 2 equals root 5. So r plus 2 equals plus or minus root 5. So that means I would subtract 2. R equals negative 2 plus or minus root 5. Quadratic formula. So x equals negative b, that's going to be negative 2 plus or minus 2 squared minus 4 times 5 times 5 all over 2 times 5. Let's see, negative 2 plus or minus. So remember, we always do the squared, multiply, multiply, then we'll subtract. So 4 minus 100 over 10, which is negative 2 plus or minus square root of negative 96 over 10. So I happen to know that 96 is 16 times 6, which I'm sure many of you do not know. So negative 2 plus or minus square root of 16, square root of negative 1, square root of 6, all over 10, which means x equals negative 2 plus or minus 4i root 6 over 10. So at this point, I can kind of see the 2, did not mean to scribble on that. The 2, the 4, and the 10, I can all divide by 2. And I'm going to kind of see that if I go to break this apart. So x equals negative 2 tenths, I'm dividing everything by 10, plus or minus 4 tenths I times the square root of 6. So it really could be square root of 6 in the numerator of that fraction, right? This is one where a couple different ways to write this. So negative 1/5 plus or minus 2/5 I root 6. So again, if you had left it this way, I guess it's okay. Really, maybe the best answer would be like negative 1 plus or minus 2i root 6 all over 5. That would be okay. So lots of ways to write the answer on this one. But I really want you to kind of see that evolution, what it should look like. I guess I did not box this one in. All right, last two. We've got a factor. Ooh, there's two factoring. These are the easiest. So let's see. 9 times 1 multiplies to make 9, adds to make 10. Remember to show all of your work steps when you're doing zero product property. And this is really our main idea for today, is like kind of putting this all together. All 4 of our different solving methods, being able to do them all, whether we have real solutions or imaginary solutions or complex. Last one, I can factor n out of both terms, so I have n times n minus 10. So n is equal to 0, or n minus 10 equals 0. So either n is 0 or 10. All right, so our goal is to be able to solve all quadratics today, whether they have complex solutions, real solutions, and using all 4 methods, right? So we've got our factor and zero product property method. We've got our complete the square method. We've got our quadratic formula. And then also sometimes we can just take a square root right away. So be on the lookout for all of those different solving methods. So, as always, class, if you've got questions, please make sure you ask.